Just put that. It's hiding. All right, guys. Here we go. We're going to do some graphing. Now, you're going to see that the beginning part of these questions is going to feel very similar to the work we did yesterday with finding those features. Okay? So the first thing I always do, all right, is I write down the center. We practiced this yesterday at the end of class. So I'm going to go let's go with Manny. That's fine. Go ahead, Manny. -4, comma, -3. Now, this one, I don't think we've seen one yet like this. Do you see how the one that has y plus 3 squared does not have a denominator? You guys see how that doesn't have a denominator? So what is that actually over if there's no denominator? It's actually a 1, right? So if you see that happen on any of your questions, go ahead and write in over 1. That'll help you with this. All right? The next thing I want to decide is what type of hyperbola is this? Who knows what type of hyperbola this is? What do you think, Donovan? Why did you say horizontal, Donovan? Yes, that's exactly right, Donovan. It's horizontal because the x value comes first, right? Or I should say the x variable comes first. So whatever letter comes first, so Gladys, this is new, different than ellipses. With hyperbolas, whatever letter is written first, that tells you the type of hyperbola. So if x comes first, like in this problem, it's a horizontal hyperbola. Okay? Now, A. Do you remember where we got A from yesterday? Where did we get A yesterday with our practice on the key features? That's going to give us the vertices, but I'm saying just the value for A, which is the distance from the center to the vertices. It is from 9, right? It is not 9, right? It's from 9. It's always, Gladys, again, this is different. It's always from the first denominator. Don't say that. It's always from the first denominator with hyperbolas. So this is actually A squared. So what is A? 3. Very good. All right. And then B is always from the second denominator. This is B squared. So if B squared is 1, what is B? It's also 1, right? The square root of 1 is 1. Are there any questions on that? I'm hoping, I know Gladys, you weren't here, but for the people that were here, hoping that should be okay, right? We did that yesterday. Okay, so here's what I want you to do. Take your pencil or your pen, go down to your grid. We're going to plot our center first. Our center was -4, -3. So plot that point right there. That's my last one. Now, once you plot the center, I'm going to use letter A to move and plot vertices. What direction am I going to move to plot my vertices? Left and right, horizontal, right? It's horizontal. So that letter A of 3 units, I'm going to move right 3, 1, 2, 3, put a point. Go left 3, 1, 2, 3, put a point. Those dots that I just did in red are called the vertices. I don't need you to label them as vertices. I do need you to know that those are called the vertices. Okay, so if the vertices are left and right, what am I going to graph up and down? The co-vertices. Nice. And Luke is right. I'm going to use that letter B of 1 to go up and down from the center. So up 1 unit, down 1 unit. Okay? Now use your pen or pencil and make a rectangle, but when you make it, go through all the vertices and co-vertices and make it a dotted or dashed rectangle. Yes, like this. So make it a dotted or dashed rectangle. Oh, we're not making a circle. We're not making an ellipse. We're making a hyperbola. This is the most involved of the graphing, right? The circle is the simplest. Ellipse is a little bit more complicated, but this is the most complicated. Now, you should have a ruler. I want you to take that ruler, still doing dotted or dashed things, and we're going to draw 2 asymptotes, 2 lines that go through the corners of this rectangle. All right? So if you want to watch me do one, right? But again, you should have a ruler. You're trying to do an asymptote that goes through the corners. There's 1, There's the other. Make sure it's dotted or dashed. Use that ruler to go through those corners. Everyone still good? Here's the last thing. All right, I'm going to use a different color, but obviously you're using the same color, so no worries on that. I'll use my favorite color, orange. And what type of hyperbola is this? We said at almost the very beginning. It's horizontal. So the last step is to go to the left and right of this box, of this rectangle, and draw two curves. So my first curve going through that vertex, following the asymptotes, is like that. And then my other side to finish the drawing. That is graphing hyperbola. I know, right? That's a lot. How are we doing? Horrible. Oh, my goodness. Lucky for you, we got another one.
Where do you put those semicircles?
The semicircles. You mean the curves?
Yeah, the curves.
Good question. Let me go to the curves again. Right? So everything you're going to see in a moment, Luke, is exactly the same, even if this had been a vertical hyperbola. The only difference would be at the very end, if it's vertical, you would be plotting above and below. That's the only difference. So when it's horizontal, you're going to go left and right for your curves. Vertical, it's going to be the up and down part. Okay? All right, here we go. Let's go to number 2. Flip it over. Okay, let's do the center. Let's go Jasmine. Jasmine, what is the center in number 2? Say it one more time. 4? No, it's going to be an ordered pair for the center. Okay. 7 and excellent. There's one thing I would change, though. Minerva, do you remember what we need to talk about here? The X, whatever is with the X, has to be written first. So even though you see the 7 and then the 3, this center is actually going to be
3 and 7.
Very good. Now, since you notice that the Y is written first, what type of hyperbola is this if the Y is written first? It's vertical. Now, if we get back to what, Jasmine, you said initially, 4, that's a squared, right? The first denominator is a squared. So what is the square root of 4? 2, so that's my A. And what is the square root of 9? 3, that's my letter B. Remember to stop and raise your hand and ask a question if you are confused. All right, let's plot. Go to your grid. I'm plotting 3, 7. Now, which way am I moving for the vertices? Which way am I going to move for the vertices? What type of hyperbola is it? It's vertical. So the vertices are going to move that direction of up and down. Very good. So I'm going to move up and down 2 units. These are the vertices. If I move up and down for the vertices, what way do I move for the co-vertices? Very good. Horizontally, that letter B of 3 units. So move 1, 2, 3 units left and right. And then I'm ready to make the rectangle. Don't forget to do the dotted or dashed rectangle. Once you do that, use your ruler to draw the asymptotes that go through the corners of this box. And you'll have the rulers when you're doing the test next week. Now, as you're finishing up, as I mentioned earlier, ultimately, none of this is really any different in terms of this process. Yes, I know I moved a different direction for like vertices and co-vertices, but everything's very similar. All right, and the last part is to decide where are you going to put your curves, right? It's kind of 4 options here. We have top and bottom, left and right. Always go back to what you wrote down. What type of hyperbola is this? Vertical. So I will be graphing up and down for my curves. So my curves are up and down. When I grade this next week, I'll be looking for your curves following the asymptotes, but not crossing them. So try your best to make the curves get close, but they should not cross those asymptote lines. One more time, Gladys.
I was saying how mine didn't come out like this.
I think just do your best, right?